Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on another subject, which is material science and engineering. So today we are going to discuss about elastic and plastic behavior of solids. So basically we are discussing the mechanical properties of solids. Okay, so first is the concept of a rigid body. So a rigid body is basically a solid object, a hard object, which has a definite shape and size. Okay, so it can be a cube, it can be a cylinder, it can be a sphere, it can be a cone, any shape, any random shape. If it is hard, if it is well defined, it has a well defined fixed shape and size, then it is called as a rigid body. That is the concept of a rigid body. But in reality, the solid bodies, they are not perfectly rigid. That is, their dimensions can be changed on the application of force. Okay, they can be stretched, they can be compressed, or they can be bent. Okay, to change their shape and size. So they are not perfectly rigid. Now, it is after the deforming force, that is the external force which is applied, it deforms the rigid body. Okay, after this force is removed, how the body behaves, that gives rise to elastic and plastic behavior of solids. We can categorize depending upon their reaction after the removal of the deforming force, after the external force is removed, how they behave. That gives us this two categories, that is elastic and plastic behavior. Okay, so when an external force is applied, a body undergoes change in its shape and size. This process is called as deformation. Okay, the body undergoes deformation. Okay, that is change in its shape and size, and the externally applied force is called as the deforming force. Now, once the deforming force is removed, some bodies, they return back to their original shape and size, their original, dimension, length, breadth, height, angle, everything, they return back to their original shape and size, while others do not return back, they do not regain their original shape and size. So this tendency gives rise to two broad behaviors, that is the elastic and plastic behavior of solids. So there are two properties here, elasticity and plasticity. So what is elasticity? What is the property of elasticity? Now, if a body, it returns back to its original shape and size, if it regains back its original shape and size after the external deforming force is removed, then it is called as an elastic body, if it regains back its original shape and size. Okay, so this is the initial rigid body. External force is applied. It can either lead to change in length, breadth, height, or it can lead to bending or anything, any type of change in shape and size, change of dimensions. Now when the force is removed, it again returns back to its original size. The initial is same as final. So this is called as elastic behavior, and the property is called as elasticity. Again, there are two categories, subcategories here. One is called as perfectly elastic body and another one is not perfectly elastic body. Now, the extent to which the initial and final size, they're close, that gives us whether the body is perfectly elastic or not. Suppose after the deforming force is removed, the initial dimension is exactly the same as the final. That is, the body, it totally regains back its original shape and size, totally regains all the previous characteristics, 100%. Then it is called as a perfectly elastic body. If it completely regains its original shape and size almost immediately, that is called as a perfectly elastic body. Okay, there are numerous examples here, but for a simple concept of elasticity, you can take the example of a rubber band. When it's stretched and when the stretching force is removed, it returns back to its original shape and size. Similar case can be done for a spring. When it is either compressed or stretched, and when the compression and stretching force is removed, it returns back to its original shape and size, the original position. Okay. Similarly, other examples can be of silicon, which is used for various purposes. It is also an example of elastic material. There are several other examples here. I have just mentioned a few. So, elasticity is the property of a body to regain its original shape and size after the removal of the deforming force. And if a body completely regains its original shape and size, then it's called as a perfectly elastic body. And this is the concept of elasticity. Next is plastic behavior or plasticity. Now this is the complete opposite of elasticity. If a body does not regain its original shape and size, it does not return back to its original shape and size, and the change in shape, the change in dimension is permanent, then it is called as plastic behavior. This property is called as plasticity, and it is called as a plastic body, and this property is called as plasticity. If a body does not return back to its original shape and size after being deformed by an external force. And here also there is perfectly plastic body. Now suppose a body does not show any tendency, okay, it completely remains in the fixed position after deformation and does not show any tendency to return back to its original shape and size, that is called as a perfectly plastic body. Okay, so it does not show any sign of returning back to its original shape and size. So this is called as a perfectly plastic body. It is completely opposite to the concept of perfectly elastic body, where a body completely regains back its original shape and size. It completely returns back to its original shape and size after the deforming force is removed. Whereas for perfectly plastic, the body totally shows no sign to return back to its original shape and size after the removal of the deforming force. Okay, so perfectly plastic body remains 100% in the deformed position. There is 100% deformation. Okay, 100% deformation. So it is permanent deformation. So example of plastic behavior for a simple plastic behavior is the concept of to explain plasticity. So we can take a real life example of chewing gum. Suppose we chew it, we apply the deforming force, the teeth, the jaw, it provides the deforming force, and the size of the chewing gum is altered. Okay, but it's somewhat flexible. It shows some sign of elasticity. It is not 100%, so it is a simple plastic behavior. Its changes, or the change in shape and size is permanent, but it's not 100%. Whereas if we take the example of candle wax or clay, here the change is 100%, like a perfectly plastic body. Paraffin wax, candle wax, or wet clay, after it's molded in different shapes and size, it is baked and it is permanent deformation. So Here are some important examples of elastic and plastic materials, and another example will be the bending of metal in different shapes and sizes. So this also leads to deformation, and it shows no sign of returning back to its original shape and size. So here is the concept of elastic and plastic behavior of materials. So every rigid body, it can be classified into two categories: elastic materials and plastic materials. Elastic materials, they return back to their original shape and size after being temporarily deformed by the external force. Plastic materials, they do not return back to their original shape and size, and the deformation in shape and size which happens because of the external force is permanent. Again, the nature of deformation can either be absolute 100%, or it can be to a certain extent, let's say 50, 60, 70%, and that leads to perfectly elastic body or perfectly plastic body. If the deformation is 100%, it is perfectly plastic. If the deformation is 0%, it is perfectly elastic body. Okay, so the nature of deformation that gives rise to perfectly elastic or perfectly plastic body. If the deformation is 100% and permanent, it is perfectly plastic material, and if the deformation is 0, that is the material completely regains its original shape and size, it is perfectly elastic body. So we will discuss more on such concepts. This is just a basic introduction. So this is the okay.